It's common knowledge that there is a dire scarcity of drinkable water on Earth, even though our planet is predominantly covered in water, 71% to be exact. However, 90% of that water is situated in the oceans, rendering it undrinkable due to its salinity. The remaining 3% isn't readily available either. This water scarcity raises an interesting question. Why don't we manufacture water chemically in laboratories? After all, its formula, a combination of hydrogen and oxygen, is well known. Unfortunately, that solution isn't as straightforward as it seems. The combination of hydrogen and oxygen atoms releases a massive quantity of energy. Hydrogen, known as the simplest element, only has one electron in its orbit. Oxygen, on the other hand, falls 2 electrons short of filling its outermost shell with 6 electrons. To fuse these two elements, an energy barrier must be surmounted. Considering hydrogen's highly flammable nature and oxygen's propensity to support combustion, the energy produced by their combination could lead to a massive, fatal explosion when conducted in large quantities. This volatile reaction was tragically demonstrated in the 1937 Hindenburg Disaster, where the German passenger airship LZ-129 Hindenburg caught fire and was destroyed when attempting to dock with its mooring mast. The fire was triggered by an electrical spark resulting from static electricity buildup on the airship. Given the abundant oxygen in the surrounding air, it rapidly reacted with the airship's hydrogen, culminating in a deadly explosion. Despite the catastrophe, the reaction indeed produced water. Constructing water to accommodate the needs of our planet's vast populace would require laboratories and facilities capable of containing such an immense release of spontaneous energy. Unfortunately, this would be prohibitively expensive and therefore economically unfeasible. However, an alternative solution does exist. Instead of creating water, we could extract it from the air, where it readily exists as water vapor. By rapidly decreasing the air temperature using cooled metal sheets, the water vapor condenses. The Whisson Windmill is a machine that operates using this principle. It generates around 12,000 liters or 2,600 gallons of water each day, at a meager cost and minimal environmental impact. On a smaller scale, portable water makers are now employed in disaster-stricken areas. They operate by drawing air through a cooled chamber, producing up to 545 liters of water per day. However, manufacturing water isn't as simple a task as it appears, so our best solution for addressing water scarcity is conserving the water to which we already have access.